ready?
We're ready.
You read the scales. I'll have something whacking in the head over here. Should I wear a helmet?
Okay, we're at zero-ish.
Zero-ish. Now we know we're good to 200, right?
Hold.
What are we at?
The scale is rotating, is moving, migrating.
God. Which
so
one?
Back off. I mean, the whole thing's just sort of rolling forward because this isn't quite vertical here.
Oh.
So just back off. And just move it a bit. And put a little block under the wheels.
Oh, it's going that way. Oh, yeah, of course.
Okay.
Ready again?
Yep.
Okay. I wish somebody had done a little bit of engineering on this.
Yeah. Just needs a little tuning.
What are you at there?
30.
And 20 over here?
Oh, sorry, 130.
130 and 20. 150. What are you at now?
160.
And 22. What are you at now?
180.
And 25. So that's 205. That's about where we were before. One more pump. What are you at now?
210.
What?
210.
210 and 30 here. That's 240. Pretty good.
Sagging over time.
Oh, what are you at?
230. 225.
225. Is it drifting?
Yeah, 220.
Why is it drifting?
That's what I'm
Something's
wondering.
given.
Like, is there, like, maybe is there...
The only thing that can cause that is something is moving or giving. I'm holding pretty. No, I'm drifting down here too. Something's oozing. Oh, the rib is. Oh, yeah, we got some. Oh, look, we got buckling. We got buckling going on here.
Oh.
On the caps.
Oh, interesting.
Well, because this would be a full sheet.
Yeah.
Right, and that's an open edge.
All right. So yeah. So I definitely see a little.
And I thought about putting a wrap over this to try to represent the rest of the skin that would be here. But I was hoping the rib by itself would carry the load without the caps.
Right.
Well, what are we at now?
200.
And 30 over here.
Not moving anymore.
230.
Oh yeah, I can see the whole rib.
What are you at now? I'm at 32.
250.
280. Let's take it to 300. That's 3 G's at 300. Are you there yet?
Nope. 270, 280.
Oh, there went something. 280 and 40 over here. So that's 320. And something popped. Something up front here.
Yeah, something up front. It was not clear whether it was a slip or a fail.
Or the tube, the carbon fiber tube that the metal tube is running through. Because I see a gap here now. Let me feel underneath. No cracks there. It might have been internal, hard to believe.
Definitely kicked off some dust.
Yeah.
When it popped.
I don't see any cracks on this side.
You definitely see some buckling on that top.
Oh yeah,
piece.
definitely. It's in compression.
And when
it's not designed to take compression.
And when you push on the jack, you can see
It goes much more.
You can see the whole thing
Begin to bend.
Take the load and flex.
I don't know what went up here. So let's go a little bit more. Maybe we go till it breaks and find out where it breaks so that I can reinforce it and do it again later. I probably should have closed off this cap, huh? On the edge, so we weren't getting the buckling.
I know not.
Are you ready?
Yep.
Oh, I hear giving in the wood up here. Something's going to go. What are you at?
270.
What are you at now?
290.
Plus 40. What are you at now?
300.
I hear foam giving. You're at 300?
Yep.
And I'm at, right there is 380. If I push a little harder, there, that is 400. That's 4 G's. What are you at now?
Well, when you push down on your lever, it takes the weight off of the scale.
Okay, what do you got now?
270, 260.
And I'm at 130, so that's 400.
Oh yeah, I got buckling on the tip.
That's 4 Gs.
Out of the front leading edge, there's severe buckling happening there.
Really? Up in here.
Yep. Was right here. This layer right here was like creasing up.
Oh, well, that's where there's a seam here on the carbon
Like
fiber.
right there. It was kind of folding.
And I heard foam giving. Okay, well that tells me a lot, right? So
yeah, it took the load.
Before we blow it apart, it took 4 Gs. Before we blow it apart, during the week I'll come back and I'll reinforce this front area here, and I'll wrap this edge. I'll put a strip of wood on here,
right,
and then I'll wrap it with carbon fiber to simulate the rest of the skin. Because we know we got more skin, got another rib,
right,
that'll help carry the load. Because the loads will get spread out over that stuff. And buckling it like this is at the edge is not representative. Obviously, in real life, it's not going to buckle. And because of the way I made this, it was so hard to get this wetted out at the edge and stuck down. Because as soon as because remember, I cured this side first, and then I laid this side wet.
Right.
And as I bent it down, I get all these buckles in it.
Right.
Because it's at the edge. A big sheet would stay stuck to the foam as you bend it down.
Sure.
So, and I see buckling over here, I see compression of the foam here. So what I'll do is I'll fill in this front end, with structural filler up front, and then overwrap, and just really reinforce it.
Yeah.
What it says is that, what this tells me at this point, is that this D-tube that wraps around the front needs more layers, right? Not going to get by with just one layer of carbon fiber wrapped around the front on each side. Or it needs a different core material, a stronger core, which is what I was doing on the first design. I had the honeycomb, which was potted with epoxy, right? Much stiffer than the foam. The idea with the foam
with epoxy, and that's specific gravity near 1. Could you use a plywood at that?
It won't bend.
Well, no, but
I'd have to do multiple layers.
you'd have to slit it, or do layer it.
I would have to mold that first, and then build it into the layout. Very complicated.
Right.
The honeycomb with the epoxy in it, much better.
Oh, and with
because it's got great compressive strength.
Sure, and you can fill it with beads to get the density down.
That's what I did. That's what we did when we built the test wing.
Yep.
And that's got much better compressive strength than the foam. And we know that molding process works because we did it.
Right. Cool.
Okay, I thought I'd take a minute here to show you some of the changes to the test setup for the pilot support rib. Here I've substituted a bottle jack for the car jack that I was using. Because of the configuration of the car jack, it wasn't possible to get it accurately centered over the 2 scales. As you can see now with the bottle jack, I'm able to push the 2 scales together and center the jack directly over the 2 scales. Now it became important to shim the feet under the scales so that they're loaded up equally. It was pretty easy to do, but necessary. Otherwise, one would read 20 pounds more than the other one. We want to make sure that both of these scales can get up to 300 pounds, so we hit the 600 pound load that we want to put on the rib. In the back here, same kind of setup. Got a 2x4 to distribute the load on the rib. I haven't changed the pivot here at all. Up at the front, we have a steel tube in place of what would be carbon fiber for the final configuration, which is fine. And you'll note here in this area I have reinforced the area that failed previously at 4 Gs. It is interesting how it failed. There is, in this area right around the tube, there is a block of wood. There's basswood here instead of foam for the core material. The core material is Lastifoam, 4.5 pound. Up here, the basswood that was in here, right where the basswood ended and the foam started, and there is a shape to the basswood like that. Right where it ended is where the stress riser started. Now, coincidentally, just by happenstance, the adhesive between the rib cap here, which is essentially the skin of the wing, the adhesive between the rib cap and the rib itself was actually half missing at that exact same point where the wood ends. In addition, there was a splice in the graphite material that's on the cap strip at the same point. And on the other side, there was actually a bubble in that graphite skin on the cap material. So there were four minor flaws, all concentrated at one point. Actually, the end of the wood and the foam, it's not a flaw, it's just a fact of how I designed it. So I cleaned up the whole area that had buckled and pulled loose, put in a layer of graphite to replace what I had to pull off, and then I put doublers on here. I put a doubler on this side, doubler on the other side, and I actually wrapped the doublers up around this tube here to help reinforce this joint. In addition, we saw some buckling in the foam up at the leading edge, so I removed all of the foam from the core here, took off the outer skin, removed the foam core around the leading edge, and I substituted honeycomb core material, wrapped it around there, and then I filled the honeycomb with epoxy and microballoons, making a very solid leading edge. Not going to get any buckling of the foam there. Probably have to do that in the final configuration also. And finally, what I did is the caps here that represent the skin of the wing, I had left the end of the sandwich panels open. It was just easier that way. It's not really representative of how the loads would be carried in the skin, because these loads are going to be spread out over a wide area instead of terminated, of course. And we were getting bending and local buckling and separation of the skin from the foam. Really not representative of how strong it'll actually be. So what I did here is I rounded off the edges, and I took some 120 fiberglass and just wrapped it around like this, and down around. You can see it on the inside here, all the way around like this, to close off these the ends of the panels, and thereby simulate, come somewhat close to what a full skin would actually be, the strength that's related to that. So this should be much, much stronger. I should point out I was unable to change the wood here. I will change the final design. The wood here actually terminated at a little square corner, and I'm going to taper that wood out over a longer distance so that we don't get a stress riser at that point. So, and there will be doublers here on the final design. I think the doublers are important up front. They take tremendous, rib takes a tremendous load up front here. The cap strips that are inside the rib did not fail. They're very thin, that pultruded carbon fiber, and they just flexed about that point. There was no failure there, so I didn't have to make any changes or repairs there. So we should be good to go here. I'm going to set up the camera on the tripod, and we're going to give it a go, see if we get it up to 600 pounds. If it goes 600 pounds, we have a good design, and I can move forward with assembling the center section of the wing. Here we go. Okay, here we go. I'll try to read off the numbers from the scales as we head on up here. Currently we're sitting at about 8 pounds on each scale. There's 50 and 55, so that's 105, a little over 1G. Take it up to 100 here on that scale. There's 100 there, 115, 215, a little over 2 Gs. Yep, heard a little popping. Don't know what that was. Probably the test stand. Do a little more. There's 150 and 170, so 320, a little over 3 Gs. Let's see if we can take it, make the 4 Gs again. There's 200 on one scale, 180 on the other, so that's 380 close. There's 190 and 210, so there's 4 Gs. That's where we failed last time. So let's try to take 5. Get up to 500 pounds total. There's 200 and 220. There's 210, 225. There's 220 and 220. So that's 440. That let loose. Well, the rib held up, but the test stand disassembled itself. We're going to have to come back, put some screws in this so it'll hold itself together and stabilize that jack. So we'll be back for that. Okay, here we are. I put my old buddy duct tape to work. We got things a little more secure. I put some screws in down at that end, some extra tape, hold things together. Also got myself a longer stick because I decided I'd like to be further away from this next time it decides to come apart. So we're going to run it up to 4 Gs pretty quick here and then move forward from there. We know it's good at 4. Okay, here we go. Yep, I see we're out of alignment already. Gotta bring her back down. Let's get this lined up a little bit better here. That last. Let's get the valve tightened back down. Take it back up again. We're sitting at almost 0 and 0. And here we go. And stand back. We're up at 120 and 60 it looks like. Yes. We're at 160 and 80. Well, it looks like we're a little imbalanced here. There's I got 200 on one scale and just 90 on the other. Looks like I'm going to have to make some adjustments on the scales here. Let's see if we can't take it up to 400 here. Whoop, there it goes again. That's going to be a problem. We're going to have to fix that, find some other way to stabilize this test setup. Come back for another try. Okay, we have it preloaded now at 1 G approximately. And we'll see if this will be a little more stable this time. I have a line tying it off to a post. So let's just zoom on up here. There's 140 and 120, 260. Come up on 200 on this scale. Scales are imbalanced again. There's 360, so 3.6 Gs. Oh! Yeah, failing and buckling. Take her back. Looks like the side cable I had on it invalidated the test. It put some unusual loads on the rib. Wasn't allowed to move the way it needs to move. I don't see any failure other than the, looks like the pivot point here sustained some damage. Yes, it's pretty wobbly there like that. It wasn't allowed to free float like I needed to do. Put a side load, put a twisting load on this way that twisted this way, which is, it's not designed to take loads in that direction. So, on to another plan. I'll bring you guys back when I have a better idea. Okay, we have a new test setup for the pilot support rib, modified from what we had before. The two scales are now on a wide platform that supports their feet in a more stable fashion. That platform is actually screwed to the 4x4 that's underneath. That 4x4 has been stabilized in the test rig so it can't tilt sideways. Put a bunch of shims in there. And then the jack itself is on a wide platform. Spread the load out, give a more stable base for the jack, and the jack's actually screwed to that platform. The jack will still have a tendency to squirt out sideways, but I hope to get up to 5.5 Gs. If we get in that range, I'm going to call the design good and go from there, because there's going to be lots of margin. There's extra rib and the skins and all that. So let's give it a go, see if we can get there. Okay, here we go. We are sitting at about 7 pounds on each jack, so almost nothing. So let's run it on up there. There's 70 and 50. There's 95 and 65. There's 115 and 80. There is 137 and 92. Better get my head out of the way before I get whacked with flying parts. There is 160 and about 105. There is, let me get out of the way here, there's 180. Nothing's twisting sideways yet. There's 178 and 112. Take it up some more. We know we've been here before. There's 220 and 138. There is 248 and 153. I hear some creaking. Something's going to give here soon. Let's see, we're at 240, 150. That's 290, 390. Let's go one more. There's 270 on the one scale and 165 on the other scale. So that's 365, another 70 is 300 and something. We're at 295 on the one scale, 180 on the other scale, 300, 480. That's almost 5 Gs. Here we go. There's 320 and 190. That's 4. That's 510. There's 5 Gs. There is 200 and 345. So that's 545. That's 5.5 Gs almost. There's 210 and 375 and 210. That's 585. That's 5.85 Gs. I see some buckling in the skin here. That would be nominally the lower surface, which is to be expected, representing the skins of the wing. But overall, we're doing pretty good. We're very close to 6 Gs. There is 390 and oh, we made it 390 and 210. That would be 600 pounds. That would be 6 Gs. The rib held up. The test rig did not. Test rig finally jumped apart, but we made the 6 Gs. The rib design is good. We're going to go ahead with this. I see actually that part of the test fixture failed right in here. The fitting to take the bearing loads of the pivot point failed. But obviously this is not the actual design. It's not going to be like this. There's going to be a big spar going through here, so this is not representative. But the rib itself that takes the bending loads is plenty strong enough. We're good to go. So the design is fine now. With the reinforcements that we put in up front, we're good to go. So hopefully this is the last significant structural test I have to do until we test the all-up wing. And I can go ahead and build the center section of the wing. We know that this design is sufficient to support the pilot. So, woohoo! Yay! Bye for now.